Okay, so hello and welcome back to another Unity tutorial. In this one, I'm going to be continuing with the inventory series that I've been doing. I've done about 4 or 5 videos for it, I think. And I haven't done one in about 2 weeks, I'm guessing. Maybe longer, maybe less. But I know people are still wanting to see more, and there's plenty I can still do on it. Because, for example, I can add a hotbar, I can do picking up items, and so on. Though, since I haven't worked on it in a while, and I've been working on my game and improving my game's own inventory system, there's a lot of things in this that I actually want to improve. So this video is going to be all about optimizing what we've done so far, improving it, making it just better, using better practice techniques, making it easier to manage when we want to add to it, especially when we want to add a hotbar and like maybe some other, item holders. Basically, we want to make it modular so you can add different kinds of things. So if we want to add armor equipping and item slots for that, and so on, we can easily add those. So this video, if you're watching, is going to be taking the code that we've got up to so far from whatever episode, and making it much better. And it's going to be probably quite a long video, maybe 20 minutes or so on, because there's quite a lot I want to do and moving things around and tweaking it. But I do have my own code for reference, so I know the kind of idea I want to go for, because it's just much better than what I kind of made up off the top of my head last time. This system that I'm going to show you is much better. I want to start off by saying thanks to Paul Robinson and Phil Bourne for the $5 donations on Patreon. If you want to help support, then the link's in the description. Which one? Paul has asked me to do a video or two, or however long it takes, on the Steam Developer Kit. So basically, this video is optimizing this. My next video will be adding, picking up items, because that's what someone wants to see. So like how to actually add items without a stupid button on the screen. So we'll make a quick system for that. And then the next video after that, I will try my best to make that Steam Developer Kit video. That's just to do with basically using Steam's API and also for like releasing games on Steam. I'll need to look into it basically, because I've not released a game on Steam yet, but I'm hopefully going to eventually do that, so I still need to look into it at some point. So yeah, let's get into it. So if you aren't where we are currently, then obviously watch the videos beforehand. So there's a few things I want to change. Now, one, we have 20 scriptable objects, one for each slot, which, isn't the best idea. It works and it's fine, and then you can save to a file. I don't know if I've done saving the inventory in this. I did save a video on saving, so it's the same premise for this. But I might add that to this series as well when I get to that point. But currently we have each inventory slot as a different scriptable object, and when we move items, we clone the data across. Now, that works, and I used it for a while and it worked, and there's not really a problem with it. It's just a bit messy, and there's plenty of better ways we can do it. So what I'm going to change is I'm going to have one scriptable object for the inventory, and all of these slots are actually just going to be like a class on the inventory. And I'll explain that when we get to it. So currently on here we have inventory handler, and it's pretty messy. So we're going to be changing that. Now, obviously, as I said, I'm going to have the code on my other screen so I know what I'm doing. Like I can remember what I did on mine. So let's open the inventory script, and here it is. It's not that much. It's only 80, 90 lines. So, and then, oh yeah, that was just for a different video. Okay, so what we're going to do first is we're going to make the inventory a not a mono behavior. We're going to make it a scriptable object, and it's going to store the inventory slots, these items. I'll show you. Okay. First of all, what we want to know how many max slots we have on our inventory. We're actually going to call this, we'll call it, let's remove from our object. We're going to get rid of this inventory script off here. Okay. And let's just make it not an instance anymore. This is going to be a scriptable object. So this is going to be the base class for all things that hold items, so hotbars as well. We're going to derive from this. So we're going to have item holder, which is a scriptable object. It derives. Okay. And now we're going to work down this script, changing one bit at a time. So first of all, we need to store the max slots. I mean, I don't think we need to store the max slots, to be honest. Yeah, it's really just going to be how many we leave it to be. So, you know what, we won't have the max slots, we'll just have this list. So rather than a list of item, we're going to have a list of item slot. So a public list of item slot called, item slots. So let's just go and change it. Item slots. Okay, we don't need this. So what we're going to do is we're going to get rid of this. We don't need to know what an empty slot is either. Look, we're going to get rid of lots of old bad code. So we don't know what item slot is, so we're going to make a local class. And basically what that means is you can still use this class from elsewhere, but you have to say item holder dot, item slot. I could very easily just make this a separate object, but because it's only related to this, I feel like it makes sense just to make it in here. So it's a serializable class, which means that we can edit it on the inspector. And it's a public class called item slot. And we open it like that. And what does an item slot hold? Well, every item slot's going to have an item. So, public item. And it's going to store how many we have in that stack. So public int current stack. Now, the reason we do this is because scriptable objects, if you change them, they change everywhere you reference them. So what we're going to do here, this item data, we're never going to touch it. We're gonna get it, like we're going to get the name, get the price. We're never going to set the name or price. So any data on here which could change, we're going to not have on it. So for example, the current stack, we're not going to store on the slot. We're going to store it, we're going to store it on this new class with a slot, but not on the item. So we can have this item referenced in many places, but it doesn't matter how many we've got in the different places because we store the stack with it. That's a much better system. There's no void start because we just don't, you can't have mono behavior events on a scriptable object, but we're going to add that in somewhere else anyway. Now, inside this item slot class, we're actually going to add some functions. So we're going to add a constructor. So basically, if we do public item slot item, and then we'll just do a set item int stack. That basically just means that whenever we do equals new item slot, we have to set you can't just do equals new and then set a blank constructor. I'll show you in a second when I've just written this. So current stack is equal to the passed in stack. So for example, if I go down here and do, I don't know, vector free something is equal to new vector free. In here, you see there's 3 different overloads, like depending on what parameters you pass in, it does different things. You're allowed a vector free with 2 things because it just sets z to 0 as you see by default. We have our own constructor we've just made, and you can make other constructors. So in a vector free, there's like 3 constructors types. We're just going to go for this one. We're going to have a function for clearing, so public void clear, and we'll just say item is equal to null. This is when we clear the slot, and then current stack is equal to 0. And then public void set new item, and this is just when we add an item to the slot, like a new item, not when we're increasing the stack. This is when we add a new item to a slot. So we'll say the item is the new item that's been passed in, and the current stack is 1 because we've got 1 of it now because we've added a new item. And then we'll go to our function for adding items. So we've already got this, so we'll just say add item. So we want to change it a little bit. So we want to go through our item slots dot length, okay? Then we're going to say if item slots I dot, and we don't want to compare names because, to be honest, comparing strings is just not great. If we compare the actual items to know if they're the same item, then that's a better way of checking. Because one problem with that is if I did have 2 items with the same name, which I probably won't have, but if I had 2 different items with the same name, which might happen if you have lots of items, there might be 2 things which are like kind of similar, so you could give them the same name, then that would cause problems, but this won't. So we're going to say if item slots I dot current stack is less than item slots I dot max stack, then we're going to say item slots I dot current stack plus plus. Then we'll add some lines in here for updating UI when we get to that. So let's just get rid of this line, and we'll return true. And then here we'll say while we're less than item slots dot length, we want to, and then we're going to change it here. So we don't care about this empty slot thing. Let's just get rid of that. So we can cut that out, and then you can do shift tab to bring indent backwards rather than tabbing. So tabbing goes in, shift tab goes back. So we don't care about this line anymore, or this really. We'll say item slots I dot set new item, because this is the bit that it gets to when it gets to this point if we have no stackables left. This is when we're trying to find a new slot. Also, this max stack shouldn't be max stack. It's the max stack of the item. An item class is still going to know how many you're allowed to have of it. That's never going to change. The current stack is what changes, so we're going to store that elsewhere. But max stack, we are fine to store on the item. Then we say, and then we pass in the item, which we get in the function here. And once we've set that, we then want to update UI. So let me just write that in so I don't forget to do that later. So update UI. All right. update slot UI. We don't really care about that in here. That's not something we do in here. And add item, we don't do in here either. Though we will be doing that in the next video externally. So what we'll do is we'll just do the coding in this video, and then actually we'll still want to be testing it. I'll do a test at the end of the video to make sure it works. So we also want to have function in here for dropping the item, but we haven't got dropping item yet, so we can leave that. So there we go. That's the item holder done. And then we will be having a, let's go back to Unity. So I've just basically taken inventory and renamed it item holder and scriptable object. So it's all messed up. So what I need to do is I need to rename this item holder, and that's the base class. Okay. So we're just gonna have to create a new C# script called inventory, and all inventory does for now is it just derives from item holder, but it currently doesn't have its own specific code. It's just going to be the exact same. I could just give the thing item holder, but the problem is I will be deriving from it and changing it, so I'm just going to prepare myself and leave that how it is now. And we also want to be able to create this, so create asset menu, file name as a scriptable object. So new inventory menu name is equal to inventory. Yeah, inventory. Okay, that's that. So inventory, and we don't need this base class thing, that's from another video. Okay, so now it might compile, though we're still missing some things. We've changed a lot. So that is the inventory. Now we're going to go to the inventory slot. So we need to make a slot UI script. So currently, what do we have for the slot UI? Let's go look. So canvas, inventory panel, slots. On the slot, we have an inventory slot script, and on the image, we have an item drag handler. So let's do the drag handler first. So, whoops. The item drag handler. I'm getting lost where my code is. Okay, so first of all, we're going to store a slot index. We don't want to have to set it. Basically, in the drag handler, it should know which slot it's on. It's helpful for various reasons. So we're going to keep the dragging and the original parent, but we're going to add a protected int slot index, and that's because we're going to be it's private, but we want to be able to use it in our derived classes when we make an inventory drag handler. So currently it derives correctly, that's fine. We have a slot index, original parent. We're also going to have an item slot, because this item drag handler should have a associated item slot that it is. So what we can do is we can say protected item holder dot item slot, and we'll call it item slot. Now this is where we can store the reference to the slot this thing is in charge of. And then what we'll do is we'll write a getter, so a public item holder dot item slot get item slot, and we'll just return item slot. This is a very common thing in object-oriented programming, to write getters and setters, because it's always best to keep stuff protected and private if you can. So rather than changing this directly, we call a function to change it. It's just good practice. And then what we'll do is we'll say in our protected, because we're going to override it, protected because it's private to the classes and base classes of it, or the inherited classes. And then virtual, overwriting it, void returns nothing, start. And we'll just say slot index is equal to transform.parent.getSibling index. So basically it's going to go to the parent of this object in the hierarchy, and then return the number, the integer number of where it is in its own, like, its siblings are the other things at its level in the hierarchy, and it'll get its index. So if it's the top slot, then it'll be slot 0, so we know which slot it is. On pointer down, we're going to say, let's just get rid of all of this, it's a mess. We're going to say, when we start dragging, is dragging is true. We're going to say the original parent is the transform.parent, so, you know, the current parent, basically. And then we're going to set parent, oh yeah, that's the way I'm changing it. Okay, so what we can do now is we can say transform dot set parent. Now the thing is, when it comes to rendering on the UI, the things that are further down on the UI get rendered on top, because if something gets rendered afterwards, it's going to be on top. You know, if you draw something and you draw something again, the thing you've drawn second is over the thing you've drawn first. So we want to, I'm going to add this. We're going to have like item holder parent. And that's basically just going to be a parent, like object, whatever that is. We'll just add it at the top as a private field. So serialized field private transform item holder parent. And basically we're going to, whatever we set that as, it's going to set the parent as that. And that's so that it can render on top when we're dragging our item around and it doesn't go under other things. And then we can do the, what we did have, get component canvas group dot blocks raycast equal false. That's just so that the game knows when we're mousing over another slot, it doesn't block the raycast of the mouse. Then on drag, this is all a mess. We'll say if event data dot button. So if the button we were pressing was the left mouse button, we will then just, you know, basically if we're holding down the left mouse button, we will do input dot mouse position is where we're setting the position of the icon we're dragging, so it follows our cursor around the screen. And then on the pointer up, we then say if it's left mouse button we are not dragging, we will set that back to the original parent and 0 and blocks raycasts. That's fine. Then we'll come down here, and we currently don't drop anything from the slot. Okay, we'll say protected virtual void, because this is getting overwritten. Drop from slot, and the reason I'm doing that is because when we're going to call this when we well, you'll see when we do the item dragging and letting go. So this is just to be overwritten. So find the slot for this drag handler and drops the item. This is all preparing for the future as well, and I don't need anything else on here. Cool. So that's the item drag handler, and now we need a drag handler for the inventory specifically. Okay. So what I mean by that is, let's go and create it. So create new C# script, inventory drag handler, which is going to derive so that when we have a hotbar, it'll be the hotbar drag handler. So this is basically, it's going to derive from item drag handler, which we've just updated, and we're going to have a protected, so it's private to this, override, which means we can overwrite the code that's already there for the start method, and we're going to run the start method, so we're going to run this code, so we're going to do that anyway, and then we're going to do our own code, which is finding the item slot, which is the, and then we're going to create the class inventory handler, so inventory handler, which doesn't exist, but we're just going to write anyway, dot instance, because we're going to have the instance dot, and then we'll store current inventory, and that's so that we could actually swap it out at some point. Dot item slots slot index, boom. And then we're also going to have the predicted override void drop from slot, where we're going to actually just do the inventory handler. So it's inventory handler, which we don't have yet. We're going to add it. Dot instance, because it's going to be the it's going to be a singleton. Dot current inventory dot drop item slot. And to be honest, we should actually, rather than referencing this every time, we should probably just store it. So for example, in here, we can just say private inventory handler, which doesn't exist. So just keep that in mind. We're going to add the class handler, and we'll call it inventory handler. And then in the override start here, we can actually just say inventory handler is equal to inventory handler, but it's going to be the class name when we've made it, dot instance. And then we can just say that, so we don't actually have to reference it every time. It's just better to cache it here. If you don't know, caching is like storing something, a reference, that you'd have to get the reference every time because it's never going to change. But anyway, that's what we need for the drag handler. Next, what do we need to do next? We need to write the, let me think. We've done the drag handler. We need to do the inventory slot UI. So have we already got a slot UI script? We do, but what have we called it? So slot. We've called it inventory slot, okay? Now, we want the inventory slot to have a base class, so we'll create slot UI. So create C# script slot UI. I know this is a lot of work, but just bear with me. Now I'm going to use lowercase here because it's camel casing. Some people would use UI capital here, but I've got used to doing lowercase so that if I had another abbreviation afterwards, it wouldn't be a long, stupid mess. At least you know where it starts and ends. So this is a mono behavior, but it's also going to be an iDrop handler, which basically just means that you can drop things on it and an event gets called. So we need to implement that. So if I said, boom, it's going to tell me, hey, implement this interface. Cool. I've done a video on interfaces. If you don't know what I'm on about, then just go back and find that video. What do we want to store in here? We want to store a protected game object icon, because that's what we had anyway. A protected integer slot index, a private text, so we're going to have to derive from the UI class, library. And that's going to be for the stack, so let's just import .ui. We're also going to store a protected item holder. This is just so we can reference it in multiple places. It's better to store it in here. So .item slot, and we'll call it this item slot. But we also will need to know the other item slot, so we'll call it a dropped item slot. Okay, and then in the protected virtual void start, so in the start method, which can be overwritten, we will say the slot index is equal to transform.getSiblingIndex, just like the other one. This is so we don't have to set it manually in the inspector. It just saves us time and effort. The icon is the transform.getChild 0. It's going to be right below it, and it's the game object, so .gameObject. And stack is going to be the icon.transform.getChild 0. Now this is just saving us all the effort of doing it in the inspector. It just, get the code to do it. Why not? It just saves us time. And if we ever change something, we just have to change this here in one place rather than dragging everything through in the inspector and setting it all, and it takes forever. I've learned that the hard way. Why did I put get child text? We want to get component text. And then on drop, we want to say the dropped item slot is equal to event data dot pointer drag dot get component dot get component item drag handler. So we're going to get reference to the script we just wrote, the drag handler, and we made that function get item slot, which is going to return basically the actual item slot that we're on about. So that's what this is. We actually want to change this because we want to override it. So it's going to be protected virtual void on drop. So that means we can override the code on it. Now this is actually quite a big script, so I might I'm not going to rush through it, but I'm going to type pretty fast. You can obviously pause the video. I'll explain as I go. So I just don't want the video to last forever. So protected void handle item drop. And what this is going to do is it's going to take in the pointer event data, and it's going to basically say, so make sure this slot is not null. Okay, make sure the slot's not null. Cool. If we've got nothing in the slot, then the item in the slot. Make sure there's an item in the slot, otherwise there's no point doing anything. If this item slot dot item name, actually I could just do dot item whatever. Oh, that's something I can improve in my code. Dropped item slot dot item. So if they're the same item, then we can say this item slot dot current stack. If it's less than this is an if the current stack is less than this item slot dot item dot max stack, so if we can still add more to the stack, then we will say if dropped item slot dot current stack is less than or equal to, and then we're going to do some this item slot dot item dot max stack minus this item slot dot current stack. So this is basically saying, theoretically, if we're going to stack it, is this going to can we just add it all and it's fine, or do we need to spill into another slot? Because obviously if the max is 10, you've got a 5 and a 4, you can go to 9. But if the max is 10 and you're adding a 6 and a 6, you're going to go to 12, it's not going to work. So this is basically saying, if we have space to just combine them together, then this item slot dot current stack plus equals the dropped item slot dot current stack. Okay, so we just add it, and then we'll say dropped item slot dot clear, which is that function we wrote which just clears the slot. So we've put the amount into here. Else, so we still want to add, we just want to combine them, but to the point where they overflow. We don't want to like have more than the max. So we're going to store an integer called stack difference, and this is just going to be, you know, the max stack of this item minus this this item slot dot current stack. So that's the difference, obviously. And then we'll say this item slot dot current stack. We're going to add the stack difference, whatever that is, and then we can subtract that from the dropped item slot's current stack. Minus equals stack difference. Okay, that is that case done. So the other else we need is if the current stack is not less than the max stack. So max stack here, else. Actually, no, wait, that's a different else. This is saying if it's not the item. So else we're going to swap item. So swap items, and we'll just pass in the event data, and we'll write that function now. We also want another else. So if we go to here, we also want to say drop onto empty slot, because that's what happens there. And then we'll say update UI. Yeah, I'm going to probably do this in a two-part video because this is going to go on for a long time. Let's just write the other functions. So private void drop onto empty slot. So what does this do? Well, it says this item slot dot item is just going to be whatever one we've dropped, right? So the item that we dropped. And this item slot dot current stack is going to be the dropped items current stack. And then we're going to empty the dropped item slot, so dot clear. That's just a nice function to do that for us. Then we want to make a function for swapping items. So protected virtual void, just going to overwrite it. Swap items, so swap items. Pointer event data. Event data, that's just the parameter that we're taking in. Now we want to basically, as you know, if you swap two things, you have to store a temporary variable of the type. So item holder dot item slot, called temp slot because it's temporary. It's a new item holder dot item slot, and as you see, that requires us to pass in an item and a stack. So we'll say this item slot dot item. That's the one we want to hold temporarily, and we also want to store the current stack of this temporarily. So this item slot dot current stack, and that's just a variable we're holding. And then we want to say this item slot dot item is equal to the dropped item slot dot item. This item slot dot current stack is equal to the dropped item's current stack, and then the dropped items item is going to be equal to the temp slot item, which is the thing we just stored there. And then we can say the dropped item slot dot current stack is equal to the temp slot dot current stack. So that handles storing a temporary variable, setting one, and setting that to the temp. So we've just swapped two items around in our inventory. Then we can have a function here for the UI, which we'll probably sort out next video properly, but refresh item icons. So if this item slot dot item is not null, so if we've got something in the slot, we'll say icon dot get component image dot sprite is equal to this item slot dot item sprite. Oh, I don't have item sprite on there, so I'll just put item sprite and I'll add it. And we'll say if this item slot dot current stack is greater than 1, so as long as we've got more than one, then we'll set the actual like times however many we have. So we'll say stack dot text is equal to, and then I'll do my new string fancy method that I think I mentioned in another video. We'll say x because it's going to be like times. That's like the little on the UI. I'll say x 50 if there's 50 of them. Then we'll pass in this item slot dot current stack. Now that's the same as just doing. I have to say. Oh, I am using version 6, am I? Oh, clearly in this project I'm not. Fine. Quickly, I'll update that some other time then. For now, I'll just say. X plus this item slot dot current stack. There you go. and then we'll say else stack.text is equal to just blank string. And then down here we'll say, so if we haven't got an item, icon.setActive false. We also want to make sure we set it to true here, so icon.setActive true. Okay, that's all the code in the slot UI. Let me just go to the item class, so item, boom. Whoops, did not mean to press whatever I just pressed. No, go away. That's all the build errors right now. So go to item, and inside item, we have it, we called it icon. Never mind. Dot icon. Cool. Okay. Let that compile. We should be getting less errors. What's this one saying? Inventory handler. Yeah, we'll create that on here. So add component. We'll create it here so it's in the right folder. Inventory handler. So just give that a second. So the inventory handler is a mono behavior that is a singleton. So we have a public static inventory handler called instance. We also have a public inventory current inventory. So that's just reference to our current inventory. You can swap that out and everything goes to that new inventory. We'll have a private game object inventory panel, I guess, and private inventory slot UI, which I'm going to make. That's the last thing to make. Inventory slot UIs. Alright, I'll do like that for this one because it's plural. Private void awake. This is just the standard code for I have this here ready, so I might as well. The standard code for making a singleton. Let's just go public and private. So in the start method, private void start, we're going to say inventory slot UI is equal to find objects of type. This isn't a good thing to do in general, but if you're running it once at the start, it's not bad. Though you could actually assign them in, let's put that as UI, because that's technically how I'm going to do it. You could just drag them in and get them referenced beforehand, but I might do that in a different video. This one's getting on long enough. So inventory panel is equal to transform.getChild 0, because this is going to be sitting on it. Private void update, and this is basically just going to say, oh, actually, no, this is for toggling inventory UI. I don't need this in here. We're going to have public void update inventory UI. So we're going to say, while I is less than inventory slot UIs dot length, inventory slot UIs I dot refresh item icons, which we're going to make. So we want to reference the game object to this, obviously. Okay, how's the video going? Oh, it's getting pretty long. This is a really long video. Okay, I'm going to close it out soon. So we need to quickly make inventory slot UI. So if I go into here, you'll see that on the slot, the inventory slot UI, so inventory slot UI derives from slot UI. We don't need this anymore. It doesn't need to store an icon or a stack. It literally just needs the start method, which is a protected override void start. We're going to do base.start, which is the code from the slot UI class. And then we'll say this item slot is equal to inventory handler dot instance dot current inventory dot item slots slot index. So basically we can access the list from the instance there. And then on drop, so let's just go down to here. So we can get rid of the update slot. We don't need that. So public override void on drop. What do we want to write in it? Well, let's just get rid of all this mess from the last video. We want to say base.onDrop, so it's just going to run the base code, and then we're going to say if event data dot pointer drag Transform.parent .name is equal to GameObject.name return. We can actually just say if they're the same object, because obviously, yeah. And then we can say handle item drop, which is the function we wrote in the base class, which we can call here. It just needs to take an event data. This also needs event data. Okay, so back on the slot UI, the onDrop should be public virtual. Okay. Are we finally there? Once we get no compile errors, I'm going to end the video, and then we can... what's wrong with this? Did I not just make inventory slot UI? Inventory slot UI. Oh, what? Inventory slot UI. And then back in here, I need to say, for the inventory slot, I just need to rename it. And then we'll end the video because the rest can be done in the next one. So, inventory slot UI. Let it compile. Drop item doesn't exist in the current inventory. Inventory, we go to item holder. Do we have drop item? Did we write that? We don't drop items yet, so no, we don't. So I can just comment that out because we don't have dropping items yet. Okay. Okay, we fixed everything. Okay, so in the next video, I'm actually going to show you setting up this code and getting it all working properly, but all the coding has been done. Next video, there'll be very little to any coding, at least for the start, while I get it all set up. But this video has gone far long enough. Obviously, it's taken a long time, but it hasn't been because of stopping. It's been because of refactoring old code, a lot of it, making it better, taking what we had and just tweaking it. And then next video will be a quick setup process in the hierarchy and then scriptable objects, but it'll save a lot of work. And I hope you understand why I've changed a lot of these things and how doing certain things have just made our life much easier, and the way we can derive from base classes to save us coding the same thing again and save time. But this video is really getting on, so if you haven't already, obviously like, subscribe, stick around for the next videos. I'm sorry if the video is too long, but obviously you can watch it in parts if you want. Join the Discord server if you haven't already, help out on Patreon if you can. But apart from that, thanks for watching, and goodbye.